Your lungs are not silent, they are not passive. You have never noticed them working because they do not ask for your permission. But right now, inside the branching architecture of your respiratory tree, something is moving that you can't feel. Millions of microscopic filaments called sweeping a thin sheet of mucus, cilia, each one beating 10 to 1-2 times per second. Like a conveyor belt move against gravity. You have never felt this. You will never feel it. But the moment you stop smoking, this machinery begins to wake up. The first cigarette you ever smoked, the first time you pulled a burning mixture of tar, carbon monoxide, formaldehyde, benzene, and over 7,000 other chemical compounds into your airways, your lungs responded immediately. Not with pain, not with coughing, with paralysis. The cilia stopped beating within minutes of exposure to cigarette smoke. Not slowed down, stopped. The paralytic effect of acrolein, compound found in cigarette smoke, and also used as a chemical weapon in World War, binds directly to the microtubule motor protein dynein inside each cilium, preventing the AT-powered sliding motion that generates the beat. The conveyor belt freezes. The mucus stops moving. The debris and pathogens that should have been swept upward and swallowed begin to accumulate in the lower airways, and you did not feel any of this happening. The average smoker inhales particulate to 3 milligrams of particulate matter per cigarette, microscopic solid particles of tar, heavy metals, and polycyclic aromatic hydrocarbons that embed them in the mucus layer and the underlying epithelial tissue. Each cigarette deposits roughly 1 to 2 milligrams of tar directly on the lung surface. Over a pack-a-day habit, that is 20 to 40 milligrams of tar per day. Over 1 year, that is 7 to 15 grams of tar, the weight of 2 to 4 nickels, coating the inside of a single organ. The lungs do not reject this material. They absorb it. They incorporate it into the tissue. The macrophages, the immune cells that patrol the alveolar surface, attempt to engulf the tar particles, but become overloaded, distended, and eventually die, releasing contents back in the tissue. The lung becomes a sponge saturated with combustion residue. But here is the part of the story that changes everything. The body does not accept this state as permanent. The moment the last cigarette is extinguished, the moment the smoke stops entering the airways, a countdown begins. And the first measurable change happens far faster than most people expect. 20 minutes after the last cigarette, heart rate and blood pressure begin to normalize. This is not a psychological effect. Nicotine binds to nicotinic acetylcholine receptors in the adrenal medulla, triggering the release of epinephrine and norepinephrine, the fight or flight hormone that increase heart rate, constrict blood vessels, and raise blood pressure. When nicotine levels drop, the adrenal response subsides. Within 20 minutes, the heart rate drops by approximately 5 to 10 beats per minute. The peripheral blood vessels begin to dilate. The temperature of the hands and feet increases by roughly 1 degree Celsius measurable with a simple thermistor. The smoker feels warmer. They do not know why. At 2 hours, the nicotine withdrawal symptoms begin. The half-life of nicotine in the bloodstream is approximately 2 hours. After one half-life, the concentration drops by 50%. The brain, which has upregulated nicotinic receptors in response to chronic nicotine exposure, now has receptors that are understimulated. The result is a predictable cascade: irritability, anxiety, difficulty concentrating, increased appetite, and intense craving for another cigarette. This is not weakness. This is neurochemistry. The mesolimbic dopamine pathway, the reward circuit, has been hijacked. Each cigarette delivered a spike of dopamine, approximately 2 to 3 times higher than natural rewards. Now the baseline has dropped below normal. The brain is starving for a signal it has learned to expect. At 8 hours, something more precise happens. The carbon monoxide level in the bloodstream drops by half. Carbon monoxide binds to hemoglobin with approximately 240 times the affinity of oxygen. In a smoker, 5 to 15% of hemoglobin is occupied by carbon monoxide at any given time, hemoglobin that cannot carry oxygen. The tissues are oxygen starved not because the lungs are failing, but because the transport protein is blocked. At 8 hours, the carboxyhemoglobin level falls below 5%. The oxygen carrying capacity of the blood increases measurably. The heart does not have to pump as hard to deliver the same amount of oxygen to the brain and muscles. The smoker may not notice this directly, but the body notices. At 1-2 hours, the blood pressure begins a more sustained decline. The vascular endothelium, the inner lining of every blood vessel, has been chronically inflamed by the thousands of chemical irritants in cigarette smoke. Endothelial dysfunction is measurable in smokers within minutes of lighting a cigarette. Flow-mediated dilation, the ability of an artery to expand in response to increased blood flow, is by 30 to 50% after a single cigarette. At 1 hour without smoking, some of this endothelial function begins to recover. The blood vessels regain a fraction of their elasticity. The heart works slightly less hard. At 24 hours, the risk of a heart attack begins to decrease. This is not a long-term projection. This is an immediate physiological shift. The combination of reduced carbon monoxide, improved oxygen delivery, lower blood pressure, and partial endothelial recovery reduces the acute thrombotic risk. The platelets become less sticky. The blood becomes slightly less prone to clotting. The heart muscle receives more oxygen. The risk of a myocardial infarction, which spikes dramatically during active smoking, begins its downward trajectory within the first 2-4 hours. Not in a month, in 1 day. At 48 hours, the nerve endings begin to regenerate. Nicotine has desensitized the sensory nerve endings in the airways. The smoker has lost the ability to fully smell and taste. At 48 hours, the nerve endings begin to regrow and resensitize. The olfactory epithelium, a patch of specialized tissue high in the nasal cavity, containing approximately 10 million olfactory receptor neurons, begins to function more normally. The smoker suddenly notices smells they had stopped registering. Food tastes sharper. The change is not subtle. It is reported by approximately 80% of quitters within the first week. At 7-2 hours, the bronchial tubes begin to relax. Chronic smoking causes the smooth muscle in the airway walls to remain in a state of partial contraction. The airways are narrower. Breathing requires more effort. At 7-2 hours, the bronchial smooth muscle begins to relax. The airway diameter increases. The smoker can take a deeper breath without feeling the familiar tightness. The forced expiratory volume in 1 second, the standard measure of lung function, begins to improve. Not dramatically, but measurably. The lungs are opening. At 2 weeks, the circulation improves significantly. The small blood vessels, the capillaries that thread through every tissue, delivering oxygen and removing waste constricted and damaged by chronic exposure. Nicotine is a vasoconstrictor. It binds to nicotinic receptors on the endothelial cells and triggers the release of N-telin-1, one of the most potent vasoconstrictors known to human physiology. The capillaries narrow. The tissues receive less blood. The fingers and toes feel cold. Wounds heal more slowly. At 2 weeks, the endothelial cells begin to repair them. The production of nitric oxide, a vasodilator that relaxes the smooth muscle around blood vessel, increases. The capillaries open. Blood flow to the extremities increases by as much as 30%. The hands and feet warm. Walking becomes easier. The smoker notices they are not as winded climbing stairs. At 1 month, the cilia begin to regenerate. Remember the microscopic filaments that stop beating within minutes of the first cigarette. At 1 month, they begin to grow back. The ciliated epithelial cells that line the airways from the trachea down to the terminal bronchioles have been damaged, flattened, and in some area replaced by squamous metaplastic cells, flat cells, that provide no ciliary function. The lung has essentially replaced a specialized cleaning machine with a passive barrier. But the body does not accept this. The basal cells, the stem cells of the airway epithelium, begin to divide and differentiate into new ciliated cells. The cilia grow back. They start beating again. The mucociliary escalator, the conveyor belt, resorts. This is not a gradual process that takes years. It begins within weeks. And when it resorts, something dramatic happens. The accumulated mucus and trapped debris that's been in its lower airways for months or years begins to move. The smoker starts coughing, not a dry cough, a product cough. They bring up phlegm that is brown-black, or yellow, the accumulated tar, the dead immune cells, the trapped particulate matter. that the lungs have been holding in suspension because they had no way to remove it. This cough is not a setback. This cough is the cleaning crew finally arriving. The mucus that expelled contains measurable quantities of polycyclic aromatic hydrocarbons, cadmium, lead, and other heavy metals that have been sequestered in the lung tissue. The body is literally excreting the residues of every cigarette smoked in the past months. At 1 to 3 months, the lung function improves further. The forced expiratory volume increases by 5 to 10%. The small airways, the bronchioles less than 2 millimeters in diameter, that have been inflamed and partially obstructed, begin to open. The air sacs themselves, the alveoli, do not regenerate once they are destroyed by emphysema. They are gone permanently. But the inflammation around them subsides. The remaining healthy alveoli expand more fully. The surface area available for gas exchange increases. The smoker breathes more efficiently without knowing why. At 3 months, the immune function of the lung begins to recover in a way that is measurable at the molecular level. The alveolar macrophages, the immune cells that patrol the air sacs, have been chronically impaired by cigarette smoke. Their ability to phagocytose, to engulf and destroy bacteria, viruses, and debris is reduced by approximately 50% in active smokers compared to non-smokers. The macrophages become filled with tar particles, distended and functionally crippled. They cannot migrate effectively. They cannot signal to other immune cells. The lung is immunologically blind. At 3 months, the macrophage population begins to turn over. New macrophages, recruited from circulating monocytes, replace the old, tar-laden cells. The phagocytic capacity improves. The lung becomes better at clearing inhaled pathogens. The risk of respiratory infections, bronchitis, pneumonia, influenza begins to decline. At 6 months, the epithelial lining of the airways has undergone a visible transformation. The squamous metaplastic cells that replaced the damaged ciliated epithelium begin to be replaced by normal columnar epithelial cells with functioning cilia. The airway surface liquid, the thin fluid layer that sits on top of the cilia and allows them to beat freely, normalizes in composition and depth. The mucus itself changes. It becomes less viscous, less sticky, easier to clear. The cough that began at 1 month may now be decreasing because there is less debris to remove. The airways are cleaner than they have been in years. At 9 months, the sinuses and nasal passage show measurable improvement. Chronic smoking causes hypertrophy of the nasal mucosa, the tissue lining. The nasal cavity becomes swollen, inflamed, and congested. The sinuses drain poorly. The smoker breathes through their mouth more than their nose without reeling it. At 9 months, the nasal mucosa thins. The sinus drainage improves. The sense of smell, which improved at 4-8 hours, continues to sharpen. The smoker can detect odors they had not registered since before they started smoking: the smell of rain on dry ground, the scent of a specific flower, the faint, chemical note of tap water. The world smells different. It smells more. At 1 year, the risk of coronary heart disease dropped by 5% compared to a continuing smoker. This is not a small effect. This is one of the largest single risk reductions available in preventive medicine. The endothelium has largely recovered its ability to produce nitric oxide and regulate vascular tone. The chronic low-grade systemic inflammation that smoking causes, measured by C-active protein levels, has fallen significantly. The arteries are less stiff. The blood pressure is lower. The heart is under less stress. The risk of heart attack and stroke continues to decline, approaching that of a non-smoker over the next 5 to N years. At 5 years, the risk of cancers of the mouth, throat, esophagus, and bladder has dropped by 50%. The DNA damage caused by the carcinogens in cigarette smoke, the benzoapyrene adducts, the acrolein, the oxidative damage from reactive DNA lesions, the oxidative damage from the oxygen species being repaired bodies, endogenous DNA repair machinery. Not all of it. Some mutations are permanent, but the ongoing insult has stopped. The cells that have accumulated damage are being replaced by healthy cells through normal turnover. The risk continues to fall. At 10 years, the risk of lung cancer drops to approximately 30 to 50% of that of continuing smoker. This is the statistic that is most frequently cited and most frequently misunderstood. The risk does not drop to 0. It does not drop to the level of someone who never smoked. The lung tissue bears the permanent scars of years of carcinoid-altered cells that carry mutation in tumor genes, like tumor suppressor genes, like TP53 and KRAS, mutations that accumulated silently over years of smoking. Some of these cells will never become cancerous. Some are already on a trajectory that cannot be reversed. But the probability that any given mutated cell will acquire the additional hits required to become a full malignancy decrease dramatically once the carcinogenic insult stops. The lung is no longer bathed in chemicals that directly damage DNA every single day. The repair mechanisms are no longer overwhelmed. At 55 years, the risk of coronary heart disease approaches that of a person who has never smoked. The vascular endothelium has largely normalized. The chronic inflammatory state has resolved. The carotid artery intima media thickness, a measure of subclinical atherosclerosis, is no longer significantly different from a never smoker of the same age. The blood vessels have spent 55 years without nicotine-induced vasoconstriction, without carbon monoxide-induced hypoxia, without the oxidative stress of thousands of chemical compounds. They have remodeled. They have recovered. But here is the layer of this story that does not make it into the public health campaigns. Not everything recovers. The lungs themselves bear permanent structural changes that no amount of time can reverse. Emphysema, the destruction of the alveolar walls, the loss of surface area for gas exchange, is irreversible. The alveoli that have been destroyed are gone. The lung does not regenerate them. A 30-year smoker who quits at age 50 will have the lung function of a 50-year-old who never smoked, only if they did not develop significant emphysema. If they did, the loss is permanent. The shortness of breath that come with climbing stairs improved due to reduced inflammation and improved clearance. But the underlying structural deficit remains. The lung is smaller. The gas exchange surface is less. The body has learned to compensate, breathing slightly faster, using accessory muscles, recruiting more of the remaining lung, but the damage is written into the tissue. The same is true for certain cardiovascular changes. Smoking accelerates atherosclerosis, the buildup of plaque in the arterial walls. Quitting stops the acceleration. It does not reverse the plaque that has already formed. The plaque remains. It may stabilize. It may calcify. It may become less prone to rupture. But the artery is not the same as it was before the first cigarette. The damage is cumulative and partially permanent. And this is where the evidence calibration becomes critical. The recovery timelines that are widely published: the 20-minute heart rate nerve regrowth, the 48-hour nerve regrowth, the 1-year heart disease reduction. They are measured. They are replicated across multiple large course studies, including the British Doctor Study, the Nerdist Health Study, and the Framingham Study, the Framingham Heart Study. But they are population-level averages. They describe what happens to groups of thousands of people. They do not describe what happens to any single individual. Some people recover faster, some slower. Some develop lung cancer 20 years after quitting. Some live to 90 with no significant impairment after 40 years of impairment after 40 years of smoking. The statistics describe probabilities. They do not describe destinies. There is another layer to this story that is rarely discussed, and it involves the microbiome of the lung. For decades, the medical establishment believed that the healthy lung was sterile, that any bacteria found in the lower respiratory tract were contaminants from the upper airway. This assumption was overturned in the last 55 years by culture-independent sequencing technique. The lung has its own microbial ecosystem. It is sparse compared to the gut, approximately 10 to 1 bacteria cells per human cell in the lung versus 1 to 10 bacteria cells per human cell in the colon, but it is real, it is active, and it is altered by smoking. Cigarette smoke changes the composition of the lung microbiome. The diversity decreases. The relative abundance of bacteria genera Prevotella, Veillonella, Streptococcus increases. The pro-inflammatory community shifts. The pro-microbiome community shifts. The immune cells of the lung are constantly exposed to microproducts, lipopolysaccharides, peptidoglycans, flagellin that shape their activation state. When smoking stops, the lung microbiome begins to change. The diversity increases. The community composition shifts back toward a profile more similar to that of a never smoker. This process is not fully understood. It is not included in the standard recovery timelines. But it is happening. The ecosystem of the lung is being repopulated, and there is another system that recovers more slowly than the public health literature suggests: the immune system itself. Smoking alters the epigenetic landscape of immune cells. DNA methylation patterns change at specific genes involved in inflammation and immune regulation. These epigenetic marks can persist for years after smoking cessation. A study published in 2006 in the journal Circulation by Juicin and colleagues examined DNA methylation in former smokers and found that some smoking-associated methylation changes remain detectable even 30 years after quitting. The immune system carries a memory of smoking. The inflammatory set point is recalibrated but not fully reset. The body remembers. This does not mean the recovery is incomplete or meaningless. It means the recovery is more complex than a simple checklist of milestones. The body does not return to a pre-smoking state. It arrives at a new state, a post-smoking state, in which some systems have fully recovered, some have partially recovered, and some bear permanent marks of the years of exposure. The lung is not the same organ it would have been. It is a different organ that has adapted to the absence of smoke. Think about what that means for the person who quits. They are not restoring an original machine. They are building a new one from the parts that remain. The cilia regrow, the mucus clears, the blood vessels open, the immune cells turn over, the microbiome shifts, the epigenetic marks persist. The lung is cleaner, freer, more efficient than it was while smoking, but it is not naive. It has been through something. It carries the history of that experience in its tissue, in its DNA methylation patterns, in the alveolar walls that are thinner than they should be, in the scars of thin they should be, in the scars of healed inflammation. The body's not forget, but it does adapt. And here is the part of this story that I find the most striking, not biological, but existential. The decision to quit smoking is made in a moment. The moment itself is ordinary. A person stubs out a cigarette, or throws away a half-empty pack, or simply decides not to buy another one. That moment takes perhaps 3 seconds. And in those 3 seconds, a cascade of biologic events is set in motion that will continue unfold for decade-ventures that involve the repair of DNA, the regeneration of mycellular structures, the rewiring of neural circuits, the remodeling of vessels, the wiring of blood vessels, the gradual clearing of blood vessels that have been embedded in vessels, the gradually being embedded in tissue for years. A 3-second decision initiates a process that the body cannot complete in less than fine years. The decision is instantaneous. The recovery is not. There is a measurement from the field of tobacco research that has stayed with me. The International Agency for Research on Cancer estimates that approximately thirds of the lung costs of smoking are reversible after cessation, but the remaining 1/3 are not. The remaining 1/3 no. The body recovers 2/3 of what was lost. It never recovers the final third. This is not a failure of the body. It is a reflection of the depth of the insult. Smoking does not simply stain the lungs. It changes the architecture. It alters the genome. It reprograms the immune system. The body accepts these changes as the new normal while smoking continues. When smoking stops, the body must undo what it can, accommodate what it cannot, and continue functioning with the permanent modifications. And this is where the science gives way to something that cannot be measured in a cohort study. The person who quits smoking does not experience the recovery as a series of molecular events. They experience it as a gradual, almost imperceptible shift in how it feels to be alive. The morning cough that was present for years, one day it is gone. The smell of rain after a dry spell registers for the first time in a decade. The stairs do not feel as steep. The hands are not as cold. The taste of food is sharper. The breath is deeper. These changes do not arrive with a notification. They accumulate so slow that the person may not notice them until months later. When they realize that something that used to be hard is no longer hard, the body has been healing in silence the entire time. The last cigarette is the most ordinary moment in the entire process. Everything that follows is extraordinary. If you are watching this and you have never smoked, there is no moral lesson here. No judgment, No warning that you have not already heard. But if you are watching this, and you are a smoker, if you are in the middle of the process, or thinking about starting it, the data is clear. The body begins to repair itself within 20 minutes of the last cigarette. Not if you last a year, not if you last a month. Within 2 minutes. The chinery is waiting. It has always been waiting. The only question is whether you will let it start. The decision takes 3 seconds. The recovery takes 5 years. The body is ready when you are.